Dynamic analysis of military bunker using soil structure interaction. Abstract: a bunker is a military fortification that is designed military with the aim of protecting people or valuable goods from bombs or any types of attacks. Bunkers were extensively used during the First World War, Second World War, and the Cold War. They acted as command centers, stores for weapons, and distribution points. The project deals with the analysis and design of a bunker constructed on 3 different soil types. Though each and every bunker have mostly similar components and machines, but the analysis and design of civil structures in a plant are always done with different ideas and optimized techniques. Hence this paper is based on some new and different considerations in analysis and design aspects and optimization. In this paper, study of dynamic analysis as well as study of different soil structure interaction models is done. The structure results are found by means of ANSYS. Optimum analysis results in optimum design. As earthquake ground shaking affects all structures below ground in case of a military bunker, and since some of them must sustain or withstand the strongest earthquake ground motion, they have to be designed and checked for different types of design earthquakes. The military structure is analyzed for all the 3 soil types mentioned above, and values for parameters like total deformation, normal elastic strain, shear stress, and equivalent stress are compared, and the most suitable soil type is finalized. Keywords: ANSYS, dynamic analysis, soil structure interaction. Introduction. Modal analysis is a commonly used tool in design in an effort to reduce or avoid vibration in machine designs. A dynamic loading on a machine will introduce vibrations. The excessive vibrations will cause noise, lead to fatigue, damage of the components. Vibrations in a vehicle will make passengers uncomfortable and lead to tiredness. Every structure has its own natural frequencies. When the excitation of a vibration on a machine coincide with a natural frequency of the system, the structure resonance with the excitation force, which lead to excessive, sometimes violent vibrations, which may lead to damage of the structure. Modal analysis is used to identify natural frequencies and their vibration modes. Engineers are often required to design the system which do not have natural frequencies near the frequency of excitation loads. Using an iterative process with modal analysis, the relevant component structure can be varied to shift the natural frequency higher or lower. With natural frequency analysis, mode shapes associated with the natural frequencies can be used to decide the suitable location of support and evaluate the significance of a particular vibration mode. Modal analysis is also a prerequisite of harmonic response analysis and some further shock/vibration analysis, such as shock spectrum analysis and power density spectrum analysis, PSD, for random vibration. Objectives of the present study. 1. To calculate various parameters like total deformation, normal elastic strain, shear stress, and equivalent stress. 2. To examine the behavior of a military bunker structure in different soil conditions during seismic excitation. 3. To compare all the parameters and finalize the most suitable soil. B. Soil structure interaction. The scales of socio-economic damages caused by an earthquake depend to a great extent on the characteristics of the strong ground motion. It has been well known that earthquake ground motions results primarily from the 3 factors. Also, the soil structure interaction, SSI, problem has become an important feature of structural engineering with the advent of massive constructions on soft soils such as nuclear power plants, concrete and earth dams. Buildings, bridges, tunnels and military structures may also require particular attention to be given to the problems of SSI. If a lightweight flexible structure is built on a very stiff rock foundation, a valid assumption is that the input motion at the base of the structure is the same as the free field earthquake motion. See necessity of dynamic analysis. In design of bunker, soil plays an important role as it is constructed underground. The different parts of bunkers like its access tunnel, bunker cavern are analyzed in ANSYS workbench. Different soil strata affects the foundation conditions and bunker should be designed according to these conditions. Different parameters like equivalent stress, shear stress, deformation are calculated in this study, which helps in understanding the concept of dynamic analysis. Dynamic equilibrium equation. When the structural configuration is complex or significant dynamic interaction between interconnected members cannot be avoided, a coupled analysis approach can be used. The coupled analysis approach can include as few as 2 degrees of freedom to represent a structural system, or it can involve the use of many degrees of freedom in a single, comprehensive dynamic analysis of the entire superstructure. Responses of MDOF systems are determined from the solution of the following dynamic equilibrium equation. This equation is the matrix form of the equilibrium equation for a SDOF system. Kxt plus Cx t plus Mx t equals R t, where K is the stiffness matrix, C is the proportional damping matrix, M is the diagonal mass matrix, and XXX are the relative displacements, velocities, and acceleration with respect to the ground, and R is the applied load. Description of structure. 2 Problem statement. A military bunker project is carried out in a fractured soil mass. It consists of a series of military structures. 3 main parts of the bunker are analyzed in this study: the bunker cavern, transformer cavern, and access tunnel. The domain of rock mass with dimensions 130 m*114 m*110 m is considered. 3 joint sets are identified based on the analysis of the collected data from field survey, and the detailed information is shown in Table 3.1. 3 types of surrounding soils are considered in this paper: clay, silty and sandy soil conditions. The effect of earthquake waves on each of the soil types and the ultimate effect on the bunker structure is analyzed with the help of ANSYS.